Hello, everybody. Welcome to today's session. Today's session will be about AI and what are your career paths that you can really grow your career about. And AI you hear everywhere. AI is the next big thing you might have known by now, actually. It is really going to help the digital transformation era. And today we will see a good introduction to AI, its technology, tools, and everything. And hopefully today's session will be very useful to you. Let's get into the session.
My experience primarily comes from our own company. I've been co-founder of a vision company and we have successfully built a product from scratch which does face recognition, face emotion analysis, object detection and classification, smoke and fire detection, car vehicle plate detection and many other features. We've been operating in the Middle East region where we already have a couple of customers and we have a healthy pipeline projects where we are working on them. I've been working in this hands-on for the last 2 years, and I also have a very good business application experience of the technologies. So I can take you through hopefully a good journey of learning throughout the course. As for the agenda, we will have an introduction about AI with a short history and what has changed in the recent past, which has given to the rise of these AI related technologies. We will see the high level application areas where AI is being used today, and we will cover some of the applications, and we will jump onto the computer vision. We will see the basics of how computer vision is utilized, how it's applied, how can you think of new projects or new applications of computer vision, and we will get into some of these tools that will help you to get started with computer vision, and we will also give you a small demo about how the computer vision can be used that you can get started with it. AI as a discipline is available from 1956 onwards, when the name AI, artificial intelligence, was coined. But then there wasn't any significant improvements or developments, mainly because of the computing industry itself was not mature enough. Anything that is related to problem solving with computers, mathematical algebra, anything is termed as AI. The significant change in the AI came in the form of artificial neural networks. The rapidly evolving CMOS chips, which was becoming more powerful, aided the artificial neural network, which was formulated based on the human nervous system with interconnected neurons. And when an input is received from an organ or from a sensory device, the neurons fire each other, which results in a specific output. The artificial neural network was loosely formulated on this. After this, there was gradual development in the 90s, and the biggest significant achievement, at least the significant achievement the masses knew, came in the form of Deep Blue, which is a supercomputer from IBM. The Deep Blue system managed to beat the world chess champion Gary Kasparov in the second attempt, actually. The first attempt was a failure, which IBM took back the lessons, reprogrammed, and came back to beat the chess champion, and which is considered to be one of the significant milestones in the history of AI. And from 2000 to 2019 or 2020, there was a rapid development, which is what we see today, which is as a result of increasing research, a lot of research papers that came in, and a lot of new framework, hardware to run the AI. So, all of this developed during this time. From then, there was a rapid development in AI in terms of software and hardware both. A lot of research papers that came out, and artificial neural network got really fine tuned, and a lot of advancement like faster RCNN, convolutional neural network, and many things evolved. And very recently, we have a lot of artificial intelligence frameworks to build your own neural networks, and the hardware is being developed rapidly as well. We hear a lot of AI these days, and AI is being applied in almost every field that you can talk about. So, what changed between 1997 and today that AI is being developed so rapidly, and it's being applied to many areas. The first thing is the hardware. Everybody knows that hardware has been getting powerful day by day, but then you have never seen computer chips going beyond 4 gigahertz of speed actually. Even the fastest chip is like 3.2, 3.3 gigahertz, though Intel comes up with multiple changes and every generation after generation of i7, i series processors. There are many underlying reasons why the CPU speed is maxed out at 3 to 4 gigahertz of speed. But then the real development is actually happening on the other side when it's NVIDIA leading the race with these GPUs. So the GPUs originally which were used for the graphics processing and gaming and for other purposes are now being increasingly used for AI. And to compete, all other vendors like Intel and AMD and everybody are coming up with, even Google for that matter, is coming up with their own hardware to do AI related processing. If you compare the slide, the IBM Deep Blue computer did actually 11.38 gigaflops per second. And on the right side is NVIDIA Tesla V100. This is the the topmost graphics card from Tesla, which for the servers, which goes into a PCIe slot, and which can do 14 teraflops of speed. So this is an impressive development, and this is one of the main reasons why AI is being developing rapidly and being applied to many places. This is the software. Similar to the hardware, even for the software, we need a whole ecosystem. It is not just the programming languages or anything. So the whole ecosystem is being, the developed as a whole actually. For any AI, the first requirement is the data. You need to prepare a lot of data sets to train the AI systems. So you have to teach it actually, it's like how a kid is taught. So we have to teach the AI systems, which this is the final decision I want, and this is how the input should be, and this is how the input from the real world will be actually. So data is the prerequisite for any AI system. So the pre-search engine era, if you go back like 20 years from today, like in early 2000s, when Google was not so prominent, getting a lot of data or preparing data sets is a big task. But after the advent of search engines, after the image based search came in, whatever you want, a particular type of cat, you want a particular type of animal, or if you want a particular scene, getting a lot of data from the internet is very easy. So the prerequisite for any AI engine, which is the data, is being resolved because of the abundance of data. One through the search engines, and the other one through social networks. So the crowd or the community is being pumping in a lot of content and data through the search engine, through the social networks, and also through cloud storage. And like for example, let's take pictures, and a lot of cloud storage that is available for pictures, like paid and unpaid. A lot of content is being generated here actually. The other important thing that evolved in big time is the neural networks. So because of the availability of data and the processing power, neural networks started evolving, and a lot of research went into this. And if you read the neural network papers from the 2000 to 2010 onwards, you can see a lot of people were using uh, Google to build their data sets. Actually, the trend quickly shows that the incoming data is really helping these research to widen. So the neural networks developed with a lot of variations started coming in, called dense neural networks, convolutional neural networks, which were even fine tuned and used for certain applications. And this is one of the important factors that made AI what it is today. The recent history is, let us take the last 6 to 7 years, is when the deep learning frameworks have taken shape, which is actually driving the AI big time. Anybody who want to get into AI and do some kind of product, some kind of application, like how it was Java, .NET, and C for programming, when there is a whole ecosystem that helps you develop any sort of application for web or for traditional core applications. In a similar way, if you want to develop an uh, AI application, you have to train your models, you have to prepare data sets. So these frameworks really help people with all the tools necessary to actually get your AI related work done. So some of the most important frameworks today are TensorFlow, which is from Google, Cafe, which was acquired or being supported by Facebook recently, and then there are a bunch of other like PyTorch, MXNet, and many others which are available in the market. Which all of this is free, by the way. Like, it is like anybody can uh, take any model and use this framework to train their models, to build their inference engines, and make use of it. AI is a discipline which is now applied to almost all the field or application domains today, actually. So this is some of the broad classifications where the AI application itself is classified. For example, natural language processing, NLP, is used in many areas where human and computer interact. It could be anything like the chatbots, some of the speech, the engines like Siri or Google now, where the human interacts with the computer. So basically, what happens here is the input from the human is obtained in terms of text or in terms of speech. If it is obtained from speech, in the backend it should be converted into text before processing, and then the obtained speech is then fed to an AI engine, classified, and there is an whole discipline working behind to classify it as a question, classify, get the keywords out of this, and what the human is trying to say, understand, and finally arrive at a response for what is coming in, actually. So there are multiple areas separately AI is being involved here, right? You can if an consumer is interacting in Arabic, and to convert it into English, you need AI engine in the middle. One important limitation in this whole natural language processing is most of the research work is done in English, and more tools are available in English. So all the other languages, or at least non-European languages, are mostly dependent on translations to get this. But anything to do with the human interactions, whatever you see in terms of translations and chatbots and anything, is working under one single area called natural language processing, NLP. The second area I would say is the predictive analytics, and again this is too wide, actually applied across many domains, right from oil and gas to banking. So this is mostly on, you have a bunch of data set and you predict how, based on the past trained inputs, if you give it a current today's input on what is the values that is coming in, it can predict the future. So there are many particular models and like regression, classification, clustering of data, recommender systems, anomaly detection. A lot of applications are there in this actually, and this is more wide than the other two areas, NLP and computer vision. Predictive analysis is a very wide field, and in this there are many subdomains also. The third one is the one that is of our interest, which is the computer vision. So, computer vision, as we will see in more depth in the coming slides, is more into the getting an input from an image source like a camera or from a video or anything, and processing this image from the image source. And on this we do object detection, face recognition. So face recognition, everybody knows, is one of the important or a very common application of AI which is available today. So face recognition, object classification, counting, vehicle plate detection, and many emotion analysis. For example, any face, there are like 7 to 8 emotions can be found out from each face, like it is sad, happy, or even like other metadata like what is the age of a face, the gender, like whether it is female, male, and the ethnicity, like whether it is African, Arab, American. Such things can be derived from a single face actually. Image processing. Image processing is an discipline that is available for quite some time. It's a pretty much matured discipline. And image processing goes hand in hand with computer vision. So, what we call image processing is anything you modify in an image, like you increase the brightness, you modify the color, you cut, crop a portion of the image. So all these operations, these are image processing operations. Whatever you perform on an image is actually done using a mathematical method behind the scenes. For example, if you are changing the color in an image is three channels: RGB, red, green, and blue. So these channels are split into three and modified accordingly, and then combined to give you the new image. And if you want to rotate it, crop it, and all of this is an operation, and there is a mathematical operation which is performed behind the scenes. So the input for an image processing is from images, or from a camera stream input, or from recorded videos. Why image processing is required is image processing is hugely used in dataset preparation and for applications using AI, because any incoming image, maybe it has to be enhanced for the AI to consume it, or let's say if you detect a face, only the face has to be cut from the big image, where only the face will be processed for face recognition on a subsequent model. Next is the neural network as such actually. uh, The images that you see on the left and right are a simple neural network and a deep learning neural network. What is the biggest difference between them is, as you can simply see, the hidden layers. In the deep learning neural networks, there can be many layers between the input and the output. The input and the output here can be anything actually. For example, for computer vision, an input is an image or a frame or a video or anything, and the output again it can be like a bounding box for a face recognition application, or it could be image classification where it gives you yes or no questions answered. We will see how to make use of these neural networks, models and other things in detail in the upcoming slides. For now, let's have a quick view and let's move further. So here, let's start with a quick application, and we will see how we arrived at this particular decision making process. So here we have a screenshot from a game, Super Mario Brothers, and the character of the game is standing in a particular position in front of a brick. So now this image is fed as an input to a neural network, and we are expecting an output to tell us whether to run or jump. So based on where the character itself is standing, so the neural network should predict, analyze and give us an output of whether to run or jump. So here three things are clear actually. So the input to the neural networks is the image, and the neural networks with whatever the number of layers is in the middle, and then there is an output. The output here is just a decision based on whether to run or jump. Here is another example similar to the previous one where the decision or the output of the neural network is to run or jump. These are the chest x-rays of different COVID-19 patients, and a model is being trained and is available. So when a chest x-ray is a new x-ray is fed to a model, so the based on the x-ray in the conditions of the chest, the model can actually predict and give us an yes or no output that whether the patient will survive or not actually. So this model is available in the public domain, and anybody who wants to make use of it can use it actually. So I just want to include it here to give you an idea of how computer vision is being used across the domains in multiple applications. So the neural networks and how the image is going into the neural networks is shown in this slide. So any image for that matter is represented by pixels behind the scenes. So here is a black and white image. The application here is to detect the handwritten digits. So now here we have an image which is 784 pixels. So when this image is converted into pixel values, all the black pixels are having 0 values and all the white pixels are having the pixel value from 0 to 256 based on the whiteness of the pixel itself. So now when this is fed to the neural network, how it is being done, like each pixel is going to the neural network as an input. So in this case, the neural network should have 784 input nodes. As you can see on the right side, we have like pixel 0 all the way up to pixel 784. So each pixel is fed to this neural network, and there are many intermediate layers, and the output is arrived from now. Here only 5 nodes are shown, but there should be actually 10 output nodes which will fire one of the output node based on the input from 0 to 9 digits. So in this case the 8th node of the output will fire and it will give us a result of 8 when this image is fed. Some of the things that to be noted here is this neural network, when it is designed and defined, it will have 784 pixels or 784 input nodes. So in during the inference, any new image that is to be fed due to this neural network has to be of the same size, 784 pixels, or you can say 28 into 28 of image size. It has to be converted or cropped to this size before it goes. The other important thing to be noted here is, here all the pixel values are from 0 to 256, which is a black and white threshold image. So colored images cannot go into this particular neural network, because the image, the pixel value range is from 0 to 256 during the training phase. So this will accept any image 28 into 28 and which is only black and white. Now going back to our original example of the game. So in front of us we see four pictures actually. So in the last slide we saw how an picture is fed to a neural network. So in this we see pictures of different dimensions, and it is color pictures actually. So the original neural network for the game, it should be of only a standard size. So maybe one two of these pictures has to be converted to the other size before they are fed to the network. And also how the whole neural network is designed is based on a large data set. So in this case, now we see we have four pictures here. The first picture, the character is jumping, and the second picture on the right top, the character is supposed to jump also. And the third one, the character is jumping, and maybe it has to run after this or jump again. The third one, it has to run. So now what the process here is happening is, it is like teaching a small kid how to play this game. So basically you tell the kid, the character is here, now you should jump, and he or she presses the jump button. In a very similar way, we take thousands of images from the game, and each image we feed it to the network and tell the network this belongs to the category of jump. And we take other set of images and we tell the network this belongs to the category of run. So this is the training phase of the neural network. We take a neural network and we give it a lot of images, and we teach it this is jump and this is run. We don't tell about anything about the character, we don't tell anything about any details in the image. What we do is only one, we tell it this is jump and this is run. Whatever we discussed, the flow looks like this. We prepare the data set, which is, as we saw, a series of images, and this series of images can be classified as whether it is jump or run, or in the case of this COVID X-rays, whether it is a surviving patient or a patient which who did not survive. So the input is the data itself actually. So in terms of the patients, we need to have enough X-ray samples and some historical data about whether the patient survived or not. And we prepare this data set and we choose a model. There are many predefined models available from the framework, products. Let's say TensorFlow or Caffe or MXNet. These models, they are not something that is provided or prepared by Google or Facebook. These models are standard models that are coming out of any research publications. For example, SSD is a model which is called single shot detector. Similarly, faster RCNN is another model. So these models are standard models, and each of the framework it has its own methods to build the model in their own framework, and these models are also available pre-built. So now what we do, we choose the model and we take it, and we now train the model using the prepared dataset for whatever applications we have. Now once the model is fully trained, the training of the model may take many hours based on the capacity of our computer. For example, if you're running with two CPU on your laptop or on your small workstation, it may take up to 2 to 3 days even to train a very basic model to get a standard trained model. Once the model is ready and available, now we can test the model by giving an unlearned image. So initially you give only the images from the dataset. The model is now fully learned and ready. Now you give it an unlearned image of the similar class, and we test the model to see whether it is giving us the good result, expected results or not. We just saw like how to train a model and what is machine learning and stuff. Now let's get into some of these tools that we will learn as taking AI as a career path. The most or like the basic tool or basic programming language which everybody accepts is Python. And Python, any library that is releasing today or in the future in AI for take any area like image processing, computer vision, or chatbots, data science, or anything that comes up in AI, it is very highly likely that it will be released in Python first actually. So Python is the most go-to tool or programming language for AI. And on top of Python, like we have R, which is a language, or like it's you can say it's like an enhancement to Python. R is mainly used for data analytics and for data science areas actually. And there are many AI frameworks. The most popular are displayed here, like some of them like TensorFlow, TF, like Keras. TensorFlow is from Google, and MXNet is from Apache Foundation, and Keras is another very good framework or tool. And these are some of these tools that we can you prepare a data set and train our model with TensorFlow or Keras or MXNet. And they also they are called frameworks because they are not just tools, they give an end-to-end framework, and they even give you compatibility with specific hardware, so that like once the model is trained, there is something available from Nvidia, something available from another vendor to where the model can be deployed. So these frameworks give you all end-to-end support. There is huge prospects for AI career paths. Like what we saw now, if somebody learns Python and somebody becomes an expert in Python, he can become an AI developer. And somebody who's becoming an expert in TensorFlow or any other AI framework for that matter can become a machine learning engineer. And there are product manager roles. And today if you see like right from cloud to a smartphone or any other device, you see they claim to be incorporating some sort of artificial intelligence. From being a smart device, they are becoming more intelligent devices, mainly because all these companies are investing a lot of money into hiring and incorporating AI into their products. And anybody who's going to learn these frameworks or languages can find very good roles and in all major companies across the world.
Hopefully today's session was very useful to you, and it gave you a good idea about what AI is and what are the career paths, what you can do and how you can really grow in your career with AI as your career option. And if you have any doubts or anything, please write to us. The email ID is provided here. Thank you for attending the session again. Thank you.